So did you try to solve it by both the ways? I mean, all the you did by the Lagrange polynomial, or you did by something else?
Sir, linear and Lagrange both.
Okay. So you people also can cross check your answers. So what is your answer for the linear one?
Sir,
Lagrange one, you can tell first because Lagrange one I have the answer here.
for
So
Lagrange one, my answer was 0.
can you check your Q1, Q2, and Q3? All of you can cross check your what you calculated. Is this your Q1? Because before
Yes, sir.
solving that, you have to calculate Q1,
Yes, sir.
Q2, and Q3, right? So is this
Yes,
Yes,
sir.
Q1
sir.
is same as I have,
Yes, sir.
Yes,
Yes,
sir.
sir.
and Q2
Yes, sir.
Yes, sir. Yes, sir.
and Q3?
Yes, sir.
Okay. So if you have, then you will get your Q1, Q2 values that minus 0.125 minus means 0.75 and 0.375. These were your values of Q1, Q2, and Q3 at x equal to 1.5.
Yes, sir.
Yes.
So if you substitute that there by means using this Lagrange polynomial equation that yk qk summation of 0 to n is 1 to n, sorry. So if you substitute that, you are getting answer is 0.
Yes, sir.
Yes, sir. Yes, sir.
Then what about the interpolation answer? The piecewise linear interpolation?
That is y equal to 1.
Yes, sir. Y equal to 1.
And others, everyone got the same thing?
Yes, sir.
Yes, sir.
Okay. And any other thing you did?
Sir,
You
I have a
did
doubt.
these two much. Okay.
So in that interpolation method, we have to
Hmm.
find y at x is equal to 1.5.
Correct.
So we have to take the interval between x1 and x2, not x0 and
Right.
x1, right?
Yeah.
Okay, okay, sir.
You have to take that only, na? Because your
That
unknown
range comes in
values
that
is,
between that
yeah.
sector. Yes, sir.
Yeah. So you have to always bracket your answer first that in which segment your value lies actually. So
Yes, sir.
your x 1.5 would lie between x1 and 2. So this would be your x1 by 1 and x2 by 2 would be 2 comma 2 actually. Correct?
Yes, sir.
Hello? So you actually got the answer by 2 means. Any other thing you tried for that?
No, sir.
No. So let's see if you want to plot those values in, let's say, in Excel sheet here. Uh, your values were 0, you have 1, you have 2, right? Then you have here 6, here 0, here 2, right? These were your values of x and y, fine?
Yes, sir.
So you can write there x and y and let's plot them. Yeah, I mean how would they look like actually? So if you will plot them, this is what your graph look like actually. Fine. So is going somewhere 0 also. If you will join with a actually line of curve and if you join with let's say straight line graph here. So you can go back again to your Excel sheet. Uh, so that at the various means actually you can, let's say you want to join like this way. So this way your graph look like that, right? The another person can join maybe you are joining this way. So this way your graph is somewhere. Uh, so these were your two, but either of them should be correct, right? Yes or no?
Yes, sir.
Correct.
Yes, sir.
So either of them need to be correct only, either this one or this one. So if you will see that always actually the polynomial fit and all this, because you have to go from same data point and you are actually correlating a particular process. If you so process should have a pattern actually, right? There should be some pattern because the process is generally like that. Either you draw your concentration profile or anything else, actually temperature profile and something. So you would hardly find that you will have two type of train. Means like this type of thing. Or trained, this looks like from 0 to 1 section, you have altogether complete different process. And from 1 to 2 section look like a complete different process, right?
Yes, sir.
Because your line pattern is completely getting changed. So in that way, straight line actually this piece interpolation is not a good idea. So it looks like something like that. Now, if you will want to have a trend line for that, that what should be the polynomial, does something for that. So if you want to draw your linear is coming just like that. So linear cannot pass from all points. You can do by point, just like that. You have one point here, this way one linear, another one is here. So that is, so let's say you are doing for polynomial here. You are doing here polynomial, right? So this is the black line is your what you are fitting, right? You can change this color for time being. So let's say this color here and because just to these are just to see that what are we doing actually. So this you did a polynomial here, which is let's say you want to say the equation on this actually graph. So this is what you are getting here. Now, can we make it better? So here you have taken currently order 2, right? Second order polynomial.
Yes,
And
sir.
if you make it third order, let's say what is changing. So not change much. Fourth order, not changing much. Then let's say fifth order. And after that, you are not in position to change anything here, right? Correct or not?
Yes, sir.
Because
Yes,
if you
sir.
will just change from, let's say, previously you were here. Now you want to have a trend line for that. Let's say you want to have a polynomial. This is for second order polynomial. Let's say you are changing for fifth order. So nothing is getting changed here. Not much because fifth order is not getting fit. Because why is it not getting fit? Because your highest, your number of data point is just 3. So if you want to go to fifth order, you will have 5 unknowns and data points are just 3. So you cannot fit is fifth order. Fine. You can
Yes,
make
sir.
the order just equal to the number of data points only in maximum worst case. So if you want to do it third order, if it is getting fit, so it's not getting fit in even that order also. Then you have another type of trend here, this moving line type of thing. So sometimes it fits, sometimes it doesn't fit. So this also you cannot handle it actually here, right? So this I just want to show from here that you can have any line of fitting and all of them may not be good. So the linear is just quick estimation here, but most of the time is not advisable if you have some other technique. So therefore, your Lagrange is something better because what you have here, if you can see your data point here, your data point is this, right? X equal to 1, your Y value is 0. X equal to 2 is 2 actually. So in that case, if your another value, if you want to calculate here, so between 1.1. So if you see the graph trend here, if you see the graph trend here, it's going somewhere something like that. So you can actually format your x-axis here. So you can change your y-axis here. So it's currently 0. So you can take it, let's say, from -3. So something like that. You can see that this graph look like uh, something like this. You are talking that x equal to at 1.5, so it's somewhere here close to that. So your value is which is coming is 0 is also not making much sense because x equal to 1.5 is somewhere here, right? So 0 is somewhere here, correct?
Yes, sir.
Correct or not? So you can have some other better fit actually, which can give the answer. But obviously, this answer is much more better than your the linear answer here because it's giving value directly 1 here. At 1.5, it's coming nearly 1. I think that's why you got the answer right from the linear graph. Yes or no?
Yes, sir.
Yes, sir.
Right? So these things need to be taken care. Why are you doing that actually interpolation thing? So there are some other techniques which may provide better thing, but Lagrange is better than you can say the linear one here for time being. And this can be concluded here. So next, before talking about other interpolation techniques, so here you can have some other technique here that first we should know that what are various operators actually. So these are some of one is called power difference operator. So this is given by this del here. So if you want to say del fx actually, so you are calculating function value at x plus h and minus of fx at the previous value. So the difference between one step higher and previous one is called actually your forward difference operator, that is called del operator. If you want to say backward, means just you are going back from your the original data actually. So in that case, you are just calculating that backward difference here, that fx minus fx plus delta x. Now these are two. That another one is the center difference, that you are going from center, you are expanding from other side. Can you people mute your mics actually? Just unmute the time you want to ask the question. So here you are going the central path. You are at fx. Now total step size is just h. So you are going h by 2 to the left side, h by 2 to the right side. And then you are calculating the difference of function values here. So that's what here you are calculating f x plus h by 2. So half of the interval this side, right side, and then you are going to the back side, the half of this to the back side, so that is in the minus here. Then the another operator is actually shift operator. So if you are putting shift operator on function value fx, it means you are just moving from the older value to the higher value here. So if you put the shift operator on fx, so you are going to a function value fx plus h. So you have moved one step ahead actually. Then average operator is given by mu, so average of function fx. So you are calculating the average of this the function value based on your the central difference one, and then you are dividing by 2 here. So you are calculating fx plus h by 2 minus fx h by 2, and half of that is called the average operator actually. So this is at fx actually. Then differential operator is d. So d of fx is practically your dfx upon dx. So this is just the derivative. So in case of differential operators, you the defined by capital D, and capital D is it does nothing but dfx upon dx or f dash x only, right? So these are just the operators. Most of them you already know, at least this differential operator, and maybe I think you might have heard sometime forward difference maybe. Rest of the things are new, but not that much new actually. You can understand. Now, based on that, you have another interpolation techniques in Newton's power difference techniques. So in power difference technique here, you are going from x equal to 0 to the higher side actually. So let's say these are the data point given to you. So x data points are given, corresponding y values are given to you. And here you see the data, the means variation in x. You see the x naught to x1, you have just moved the step size h only. So if you calculate the step size between two consecutive values of your x, this is just h is fixed. So from here also you have added one h here. So you reach to the x2. So x2 is practically x naught plus 2h, because from the x naught you have moved by 2h away. So these data points are equally actually the, the spaced. So it's equally spaced, or the interval size between data are constant. So for that, now you want to calculate the forward the differences here. So if you so first forward the difference would be there. That this is either you can write in terms of I or in terms of R. That choice is yours only. So let's say delta YR would be delta YR plus 1 minus YR. So what you have here? So this is your YR plus 1, this is your YR only. So difference of these two Y1 minus Y naught would be this delta Y0, because you are calculating this forward the difference based on this value here, Y naught. Now you are calculating the difference between y1 and y2. So this y2 minus y1, you are calculating this is delta y1. Same way you can calculate y3 minus y2. This is known as delta y2. Fast forward the difference of y2. Then y4 minus y3 would be delta y3, and y5 minus y4 would be delta y4. So and then this column is known as now the first forward difference. Now you are calculating further forward the difference based on the first forward differences, and those are known as the second forward the differences here. So practically you are calculating delta y1 minus delta y naught will become now del square y naught. Same way for delta y2 minus delta y1 would be del square y1, and this one del y3 minus del y2 would be del square y2, and then you will calculate del square by 3 in the similar means manner only. So this column is known as your second difference table. Second forward the differences. The similarly you are calculating third forward the means differences here. Then fourth, then fifth. You have to keep on continue till you get only one entry at the last. Okay. So this table can be generated. Hello.
Yes, sir.
So
Yes, sir.
Yes, sir.
there the no complication here, that what is happening is just you have data, You are just calculating each point your forward differences only. So that's just y1 minus y naught or y2 minus y1, and you just keep on continue that thing till you get only last entry there. Fine. So finally, you are
Yes, sir.
converging uh, to a single point there. Now, next part here, we want to drive that. So those were that were the difference table. So we want to have a interpolation formula for that. So this I already told you that differential operator d of fx is given by dfx upon dx. Now you want to find second differential operator. So d square fx will be double derivative of the fx actually. Now you have your Taylor series expansion, right? So Taylor series, have you heard the term Taylor series?
Yes, sir.
Yes, sir.
Yes.
So you are just calculating function value fx plus h, and if you know the fx here, you know the function value, and you are just changing the small change in x here. So this is your Taylor series expansion here, fx plus hf dash x, h square by factorial 2, f double dash s, and f h cube by factorial 3, f this is triple derivative. Just wait. Okay. So you have this, and after that, what you have, we are converting this Taylor series expansion in terms of this differential operator actually. So we can write at the place of f dash x dfx, right? F double dash x, we are writing d square fx here, and f triple dash would become d cube fx. Is that fine?
Yes, sir.
Yes, sir.
Right? So after that, we are taking the fx common from all these terms here. So fx would come here. So you are getting 1 plus hd plus 1 by factorial 2 h square d square, and 1 by factorial 3 h cube d cube actually. And after that, you are this particular term here is again called e to the power hd expansion actually, this term here. So this is your exponential series, I think, right? Hello?
Yes, sir.
Yes, sir.
Right? So in that case, now you can then you have your shift operator also, the shift of operator of E of fx equal to fxs plus h. So you can write now this is the expression for u fx plus h from Taylor series expansion, which you got from here E hd and fx here. So you can substitute here this one. Fine. So in next year, let's say you want to find delta fx. First forward the difference of that. So delta fx means you are going fx plus h minus fx. Is that fine here? This is the first difference you have. Now this you got from previous the derivation here. So this practically fx plus h is shift operator of fx. You already have the fx here. So from here, if you will take the common here, so your del is coming e minus 1, or e is coming 1 plus del actually. So your the shift operator is coming equal to 1 plus of power difference, right? From here. Hello?
Yes, sir.
Now you are again here that fx plus h minus fx would be equal to, you are the substituting this from previous the derivation here. So fx plus h, you got e to the power hd fx, and you already have the fx here. So and this total thing is also known as your first forward the difference here, the left hand side. So therefore you are putting here del fx here, and here you are having e to the power hd fx. So you can take the fx common here, you can bring to this side. So from here you are getting the expression here that del plus 1 is equal to e to the power hd actually. Fine. So now you can write here that fx plus h would be equal to that 1 plus del fx, because here e to the power hd came here, and previous one, this is your expression for fx plus h is e to the power hd fx, right? So we are the substituting back here. So you are getting fx plus h is 1 plus delta fx. Now you can rewrite this equation for this one here. If you are calculating fx plus alpha h would be equal to, would become 1 plus delta to the power alpha fx. Okay. So this is just a derivation of that for time being. So first we have tried this fx plus h is equal to 1 plus del fx, and now fx plus alpha h can be rewritten as 1 plus del to the power alpha fx. ऐसा हो सकता है? Can it be?
Yes, sir.
Try करना, or I have here also, try क्या करोगे. So if you want to write fx plus alpha h, you can again write Taylor series, right? Yes or no?
Yes, sir.
Is the Taylor series, then you have the substituted the value of f dash x in terms of dfx, f double dash as d square fx, f triple dash as is d cube fx. Then you take your fx common from here, you will got here e to the power alpha hd fx, and then e to the power, you can write e to the power hd to the power alpha fx, and this you already proved that e to the power hd is 1 plus delta, right?
Yes,
So
sir.
you are just got this particular the derivation from here. So finally you can write your expression for f x plus alpha h would be in this particular format: 1 plus alpha delta plus alpha alpha minus 1 upon factorial 2 del square. Then this will keep on continue, and this is now if you will just multiply fx inside here, so this would be your delta fx is first difference, then del square y naught is the second difference, del cube y naught is the third difference, right? So this is now you have derived a formula for Newton's power difference interpolation formula here. So you can calculate your function at any value there, and probably you know the value of alpha here, because you know the x and h from your data only. Only thing from your given value you have to calculate alpha. Is that fine till here? Anything? Any doubt till here? The till this derivation of Newton's power difference formula? Hello?
So we'll go through it once, and then if you have any doubts, we can ask you.
Yes, sir.
Okay, but keep attentive during the class also, because go through once never ends actually. Now we next thing we have backward difference tables actually. So previously we have forward difference. Now we have backward difference. So same way we can generate the backward difference, the table for that. So backward difference, you are just substituting, going to the back side actually, probably from here to this side. Previously, we are going from here to this front side. Now you are going from last to first one only. So you are just putting here yr equal to yr minus 1. Second difference again is the same thing. So you can generate this particular table here. So you got backward difference y1, then y2, then y3, y4, y5. So practically you are going from your right to left actually. So this again can be generated the same way here. So derivation of this can also be done for backward difference as we did for forward the difference table. So previously we got this e to the power hd, we got equal to e shift operator equal to 1 plus del. Now you can write here backward difference of yx would be yx minus h. You are going one step back, and then you are substituting here this one e to the power minus 1 and yx minus h, because e to the power minus 1 would become that you are going one step backside. So if you are going e to the power 1, you are going to the forward side of the shift operator, and you are going minus 1 means you are going the backward shift operator actually. So therefore, you are putting e to the power minus 1 fx equal to a function value as x minus h. If you are calculating e to the power minus 2 here, so you are getting calculating fx minus 2h. Okay. So whenever you are putting e to the power minus, you are going to the back side only. So back shift operator here. So for finally you got here del means backward the difference of yx would be 1 minus e to the power minus 1. So if you substitute that, practically you are getting this e equal to 1 minus of backward difference to the power minus 1 here actually. Now we can write, because we want to calculate our function value at fxn plus alpha h only. So this we can write in the similar way as we wrote for previous one there. So this is e to the power alpha fxn, and then you got e to the power e is 1 minus of backward difference to the power minus 1. Substitute here, and again you are expanding it here as a again of this, that means the expansion of 1 minus del to the power minus alpha. So this is the expansion of that. And finally, if you will just multiply by fxn inside, so you are calculating here, you are calculating your function value at unknown point from your last point. So this is fxn is your last point actually. Previously, you are calculating it from fx naught. So you are going to the forward side. Now you are going to the last point to the backward side. So this is backward the difference formula here. So this is again same. On the only case in the previous one you have alpha minus 1 here, alpha minus 1, alpha minus 2. Here you have term plus, and these are coming with this derivation only. So these values are from your backward difference. The tables alpha would be calculated from your given data points actually. So how much away you have from your given interval size actually, that is your alpha actually. So this is the okay, यहाँ पे terms are missing. Just wait. So this is your Newton's backward difference formula here. So whenever you are interested to calculate function, just like here, if you are interested just to calculate the value close to this particular point here, last point, so you are supposed to use your backward difference. If you are interested values to calculate to the nearly to the first points, so you are supposed to use your forward difference one. Okay, so these are the some important points. When do we use your forward, your backward difference? Another one here, the central. The sometimes your data point is too large, so neither you are at close to the first data point, neither you are close to the right data point. You are somewhere in the middle actually. So for that purpose, you need to use your central difference formulation actually. And here your central difference, first central difference is given by del fx. So this is f x plus h. So and then you have minus of x minus h here. So each the step size between x naught to x1 is h only. X2 to x1 is also h. So the step size here is constant in Newton's forward difference, backward difference, the central difference. So data must be actually equally spaced only. So only then these are valid. So you can calculate here any derivative here. The of your first central difference, for that you are putting n equal to 1. Second central difference, you are putting n equal to 2. Third, you are putting n equal to 3, and keep on going. So this way you are calculating here, and this if you are calculating delta by 1 by 2, so you are calculating here, so you have here I plus 1 by 2 and I minus 1 by 2 here. So this will keep on continuing again same in the previous pattern only. The thing you have tried previously, it is the same thing, this minus that only, again this one minus this. So you are calculating your the differences based on the central the difference point, and after that let's say you have once you will solve this question, I think you can understand what we have talked so far. So this because previous one uh, there were the derivations there, but finally you have to use this expression. Actually, you should know that how to apply this part from here to here, just the derivation of that. So because sometimes we should also know that how to get it actually, or ultimately you have to use it actually. So in that case, let's say you have this in the problem here in a biological the reactor. Penicillin concentration is measured with respect to time as given below. Evaluate the concentration at time 10 hours, 50 hours, 90, 130, 170, 190, and 200 hours using forward difference, backward difference, Lagrange interpolation, and linear interpolation. So this is what you have to do first. So uh, Lagrange or linear, you already did a one short question, not a big one, just like that, because here you have so many data points, right? So first you can see here that time and concentration here, data are equally spaced, because if you see the space between 0 to 20 is 20, again 20, again 20, and 20. So these are equally spaced data points. So your Newton's power difference and backward difference can be used. So first part you have to check that whether we can use power difference or backward difference or not. So for that, primary condition is that your data should be must be equally spaced. For Lagrange, there is no such means consideration there. You can have any type of the data, and linear interpolation again no constraint there, right? So linear you can calculate much more easily, right? Yes or no? Can you do the calculation of that? Because when you should have, yeah. Hello.
Yes, sir.
Yes, sir.
So let's do for that. What comes there? So you have here data. These were given to you. You have their time here, and this is your concentration. Fine.
Yes, sir.
Yes, sir.
Yes, sir.
So can we create a forward difference table for that? आप लोग पेन पे करो. Just do on pen. So is it generated by all of you?
Yes,
Yes,
sir.
sir.
Sir. Yes, sir.
सबका हो गया? यहाँ तक तो कोई जगह डाउट नहीं है.
No, sir.
Okay. Now you have your the difference table. Now what are you supposed to calculate in question? What you have to calculate your value at first you have to calculate at x equal to 10. ठीक है? Yes or no?
Yes, sir. Yes,
Yes,
sir.
sir.
So
Yes, sir.
you have to calculate in previous formulas. You have there everywhere you have alpha there. You can see if we will talk to about your forward difference formula here. This is your forward the difference formula here. So here you have here y naught, fine, no problem. Delta y naught you are getting from there. This side is delta y naught, delta square y naught, delta cube. You have that. Only thing you need the alpha here. So alpha is practically this need to be calculated from here. Fx plus h alpha should be equal to what? क्या है आपके पास दिया हुआ? The question is this. Let's say we want to calculate here alpha here. How to calculate alpha corresponding to first point? How much is h? H, can you tell me the h?
20.
20.
H is 20 because that is the interval size. Right? What is your x? X is the any value from where you are calculating the function, right?
Yes,
First
sir.
you are calculating x equal to 10, right?
Yes.
So that is your x equal to 10. Yes or no?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
Now you have this thing x x naught plus your alpha h should be equal to your x only, because you are going to x only, no? Yes or
Yes, sir.
no? So this should be your expression for your x would be x naught plus alpha h is equal to your x only. So you know the x naught. How much is x naught?
X naught is 0.
Zero.
X
0.
naught is 0. So you can put the implied sign here. So your x naught is 0. Your alpha you need to calculate. And your h is how much?
10. 20, 20.
20.
X is 20 equal to your 10. So from here you can calculate how much your
Alpha is
alpha. So how much is alpha?
1 by
1 by 2.
2.5.
1 by point 0.5.
Alpha is 0.5. Is that fine?
Yes,
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 sir.
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 तो ये आपको अल्फा मिल गया for first unknown value, right? Correct or not?
Yes, sir.
Yes,
If you
sir.
want to calculate at value at first unknown, that is your alpha here. So you can cut here, you can paste here. Now, can you use your Newton's power difference formula now? Because now you have everything. This is your Newton's power difference formula, right? So you can paste it here. Now can you substitute everything here now? आपके पास y naught है, you already know the function value y naught.
0. Yes, sir.
These are the known to you. Delta y naught, delta
Yes.
square y naught, delta cube y naught, delta 4 y naught, delta 5, delta 6. Till delta 10 you have, right?
Yes,
So
sir.
here
Yes, sir.
delta y naught is the first difference, right?
Yeah, because if you see here this one, these are delta y naught here, delta
Why
y
not?
naught. This is the delta square y naught. This is delta
Delta
cube y
square
naught.
y naught.
And
Oh,
this is
yes, sir.
delta 4 y naught. This is delta 5 y naught. This is that. Okay.
Yes, sir.
So you have these one. So ये जो आपकी lines है, this one you have to actually if you want to line here. So these are the values you need to actually consider here. So I am making them bold. Fine. These values, your delta by naught, delta square by naught, delta cube by naught, and all this. So you have all these values. Can you substitute all of them in this equation and tell me the answer? Substitute all of them here. अभी 1-2 मिनट में करके देखो because your time is so you have this. Let's substitute the values here. So How much is y naught?
0.
0.
Y naught is 0. Fine. You got here 0. Alpha is 0.5.
0.5.
How much is delta y naught? It is
106.
106. So you can put that value here. करते रहिए साथ के साथ में 102 here. Then you have alpha 0.5. Then you have this 0.5 minus 1. Here you have factorial 2. Then you have delta square. This is this 1 3 here. So you can substitute that here, this value. Then again this one, 0.5 and 0.5 minus 1, 0.5 minus 3, and this value is this one. So this need to be inside some bracket here. This also you can put inside that. So substitute the other points also. So other points, if you will keep on doing this, so you can put maybe another point here would be how much? You have class now?
No,
No,
sir.
sir.
No, sir.
चलो कोई बात
At
नहीं
2:30 we have lab.
तो fine. So this would be your fourth difference point. At least ये formula लिख के इसको complete कर दीजिए. The fourth difference point. Then you have fifth point. So you will have your 5. So fifth difference point is this. Then you have sixth one. So in sixth you have 6 here. Six different points in this one. Then you have 7 different. It's here we have 7 difference point in this one. Then eighth difference point. And eighth difference you have this value. Then you have ninth difference.
सर वो सेकंड डिफरेंस में सर 0.5 minus 2 होगा सर वो 0.5 minus 2 सर 0.5 minus 1 0.5 minus 2 0.5 minus 3 आएगा ना सर
Second difference here.
सर ये थर्ड वाला इसमें
हाँ 2 yeah. Yes, better.
यस
What I have I wrote down something wrong here? ये 1 हो गया. ये 2. ये 2 होना चाहिए ना? What we put here? That should have
So you have also written it wrong in the main formula which you told us.
Main formula sir. Alpha minus 1, alpha minus 3.
Alpha minus 2 होना था सर आपने alpha minus 3 लिखा दिया यहाँ पे. Yes,
the
sir.
previous one.
Sir,
Yeah, I will permit it. So here we should have alpha minus 2 also, no?
Yes, sir.
Let me correct it.
सर वहाँ नहीं आएगा सर सेकंड थर्ड फैक्टोरियल सर थर्ड वाले इसमें से आएगा सर शायद.
No, let me see.
ये सर थर्ड वाले में से आएगा.
Third में तो ठीक है ना?
ये सर थर्ड ठीक है फोर्थ में -2 आएगा देन -3 आएगा वैसे आएगा सर.
Right. I'm just doing it.
Yes.
2 and this would be 3. Correct. Then here would be 1 2 3. The last one will be there. Then here we won't have this. So 1 is also missing here, no? In the 1 is also 2 is also not
The
there.
2 some are missing, sir.
2 some are
Third, fourth
missing.
equation. Yes, sir.
Yeah, we are putting that. 2. Okay, so we can write the last one. So here we have this right actually. And last difference point is this. ठीक है? Is that fine?
Yes, sir.
Okay, fine. So maybe but will always come on one page? Oh no, I have to cut it something. Maybe I can cut this one here. So you people calculate the values. Let's see what are coming. So you got that right till here is fine. You can if 5 plus 6 7 9 years okay. 6 difference point. So can you calculate all these values? What are coming?
Yes, sir. Yes, sir.
This is 10 follow for this one. You have to put in that. So actually, this way you can complete it or not. Can you complete or calculate that?
Yes,
Yes,
sir.
sir.
Yes, sir.
So I hope you can get the final answer for this one. Anyone got some values for any one of the case here? So, so in tomorrow's class, you should complete this question actually. Hello.
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so in by tomorrow's class, you complete this question actually, and then we will see what your answers are coming. Fine.
Okay.
Okay, sir.
Okay.
Yes, sir.
So we will end the class here. So in case of any doubts, you can ask it tomorrow. Fine.
Okay, sir. Yes, sir. Yes.
Yes.
Thank you, sir.
I have a
Yeah.
question. How do we have to
Uh,
submit the assignment?
Assignment you can write on your paper, A4 size sheets or any paper whichever you feel comfortable. I generally prefer A4 size sheets, and then scan it as a single PDF file. So by any scanner, or you can download Adobe means scanner on your mobile. So take one picture, complete, make a single PDF file and upload it in your Google Class actually.
Okay, sir.
Okay, sir.
Okay, sir.
Okay,
That
sir.
way. Yeah.